Pixar-style robots are no longer just movie characters. They're quietly rolling into real homes, doing real tasks, and showing a kind of warmth and personality that feels straight out of an animated film. Sunday Robotics unveiled Memo, a soft, calm home robot that moves with the gentle confidence of a movie companion. Tangible Robotics introduced Eggie, a small round robot with human-like hands and a curious way of interacting with the world. And based on how these robots look and move, it's easy to imagine kids instantly gravitating toward them. Not because they're made for children, but because their design mirrors the friendly, soft robots we've grown up seeing in stories like Big Hero 6 and The Wild Robot. For years, most robots had a very different look. Metal frames, exposed joints, stiff movements, and a posture that made sense in a lab or factory, but not in a home. They were strong and precise, but they felt cold and distant. Now, a new kind of robot is emerging: robots with soft curves, gentle motions, and designs made for everyday spaces like kitchens, bedrooms, and living rooms. Robots that look less like machines and more like characters. Hey guys, welcome to NextGen AI. Let's dive into the new generation of warm, Pixar-style robots entering real homes. Let's get started. Sunday Robotics introduced Memo, a home robot that feels like a Pixar character brought to life. The first thing that stands out is the shape. A clean white body, smooth edges, a gentle digital face, a sliding torso that gives Memo an organic silhouette. Nothing sharp, nothing industrial, nothing that signals danger or mechanical aggression. Memo looks like a robot designed for comfort, something that belongs in the same world as Baymax, built to coexist with humans, not overpower them. But Memo's design is only the beginning. What truly sets it apart is the way it interacts with the world. When Memo walks up to a messy dinner table, its movements look careful and deliberate. It picks up plates, balances wine glasses, separates food waste, loads the dishwasher, and starts the wash cycle, all with calm, measured motions that feel more intentional than mechanical. Memo then turns to a pile of laundry, organizes socks, smooths fabric, rolls each pair neatly, and places them into a basket with surprising accuracy. These aren't flashy stunts. They're relatable, real-world tasks performed with a softness that feels almost animated. There's also the espresso moment. Memo twists a portafilter with real force, locks it in place, runs a shot, and gently places the cup down. This blend of strength and delicacy is something viewers instantly connect to. Not because it's technically impressive, but because it resembles the human behaviors we see in everyday life. If you're enjoying these deep dives into the future of robotics, make sure to subscribe. More real breakthroughs are on the way. Behind these movements lies one of the most innovative training systems in robotics. Instead of relying on expensive teleoperation rigs or one-on-one human control, Sunday Robotics developed a skill glove that matches Memo's hand shape and sensor structure. Humans wear this glove in their own homes while performing natural everyday actions: washing dishes, organizing shelves, wiping counters, folding clothes. The glove captures every micro-movement: grip pressure, finger positions, torque, adjustments, and interactions with objects of all shapes and materials. Because the glove is shaped like Memo's hand, the data translates directly into robot-ready demonstrations. That means Memo learns from human behavior without needing to be physically present in each environment. To refine this further, Sunday built a system called Skill Transform, a model that converts human demonstrations into Memo's geometry, style, and motion capabilities. The robot doesn't just copy human movement. It learns how Memo would perform that same action in a robot-optimized way. All of this feeds into Sunday's foundation model, ACT. 1. The intelligence layer that handles movement, navigation, manipulation, and long horizon planning. With ACT, 1, Memo can step into an unfamiliar home, map the space, understand object relationships, and perform tasks in real time based on goals instead of scripts. It's not following rigid routines. It's interpreting the world and making decisions. Do you think simpler hands with smarter software is the right direction for home robots? Share your thoughts below. Your ideas help shape future episodes, but Memo isn't the only Pixar-like robot emerging right now. Tangible Robotics introduced Eggie, a small, rounded robot that moves with curiosity and confidence. Eggie doesn't look like a traditional machine either. With its friendly wheels, soft outer shell, and full human-like hands, it resembles the kind of character an animator might design if asked to imagine a robot that lives in a kitchen or home. Where Memo emphasizes calm usefulness, Eggie emphasizes touch. Tangible Robotics believes touch is the missing ingredient in robotics, the thing that makes human interaction with the world feel natural. While most robots avoid contact because it's unpredictable, Eggie is built for exactly that. The goal is to understand how humans interact with everyday objects. Wiping a spill with the right pressure, holding a glass without squeezing too hard, pressing a paper towel into a surface, gripping a milk carton, adjusting a slippery bottle, or pushing aside small objects on a countertop. To achieve this, Tangible Robotics uses sensor-equipped exoskeletons worn by humans. These devices capture not just motion, but tactile information, pressure, resistance, orientation, microcorrections, and physical feedback that cameras alone can't reveal. This tactile dataset becomes the foundation for Eggie's intelligence. The robot is designed not only to see but to feel, a philosophical stance that positions touch as the core of robotics rather than an optional enhancement. Do you think having full human-like hands makes Eggie more useful or more complex than it needs to be? Eggie's design reinforces this philosophy. The five-fingered hands look more like animated hands than mechanical tools. The rounded silhouette reduces intimidation and makes physical contact safer. The movements are slow, stable, and curious, mimicking the type of behavior audiences associate with friendly on-screen robots. And just like Memo, Eggie reflects a broader shift in robotics. The industry is recognizing the emotional and psychological importance of robot design in human environments. Memo and Eggie represent two different schools of thought. Memo focuses on simpler hands with smarter software, letting advanced models control high-precision tasks through learned human behavior. Eggie focuses on complex hands with tactile sensing, giving the robot human-like dexterity from the hardware level upward. One approach says intelligence can overcome mechanical limitations. The other says true intelligence requires human-like touch. Both are compelling. Both are ambitious. The next generation of robots won't look like machines. They'll look like companions,